Hi everyone, today I will talk you about the consistent hedging, like why consistent hedging is required. So let's take one real world problem and we can solve that problem using the consistent hedging technique. Right? For example, let's say uh, we have used data, right? And we have to store in the one server, so that is not possible, right? So we have to like partition that data across the multiple servers. So in often way it is called the horizontal scaling. So let's take one example. We have huge data and we have to partition that data across three servers. Okay, so let's like draw three servers. uh, this is server 1, this is server 2, and this is server 3. S1, S2, and S3. All these are database server, right? Now we have to distribute user data across three servers, and we have one load balancer here, right? Load balancer. Now the responsibility of load balancer is to distribute the user across these three database. But like load balancer have to distribute the same number of like same number of user across three data. For example, we have 6 user, then responsibility of load balancer is to distribute that 6 user evenly to this database. For example, 2 user here, 2 here, and 2 here. Right? Now let's take one simple solution. What we can use it? We can take a reminder of user ID. For example, uh, if we have 6 user, right? User user 1, user 2, user 3, user 4, user 5, and user 6, right? Now uh, we have to the logic is key reminder number of server, right? So here the number of server is 3. Now what will be the value of this? So for example, 1 remainder 3 is equal to 1, 2 remainder 3 is equal to 2, 3 remainder 3 is equal to 0, 4 remainder 3 is equal to 1, 5 remainder 3 is equal to 2, and 6 remainder 3 is equal to 3. So to server 1, which user will go there? So server 1, user 1 and 4. So user 1 and 4 goes here. In the server 2, user 2 and 5, user 2 and user 5 goes here. And in the last server, user 3 and user 6. User 3 and 6. Okay. So this algorithm working perfect means like user is distributed across multiple server. But now what is the problem here is, so for let's say one example, for example, if his server will goes down, for example, uh, uh, for example, this server goes down S1. So what will happen? So number of server is 2. So let's again calculate the you again calculate the hash of it. For example, now the remainder is 2. 1, 1 remainder 2, 2 remainder, 2 remainder 2, 3 remainder 2, 4 remainder 2, 5 remainder 2, 6 remainder 2, 1 remainder 2 is equal 1, 0, 1, 0, 1, and 0. So if you see now uh, in the uh, in the server 1, 1, 3 and 6, 1, 3 and 5, sorry, 1, 1, 3 and 5 goes here, and user 2, 4 and 6 goes here. 2, 4 and 6 here. So if you see the problem, so even if one server goes down, then we have to like movement like user data, like almost all user data across the server. Because earlier, if you see in the S2, we have user 2 and user 4. Now we have to move 1 and 3 from other server to here, and keep the 5 as it is, same way here. So the data movement is very high, right? So that is the problem here. So in the real world scenario, the number of data is used, and if any server will add or remove, the movement between data is very high, right? So what we have to do is, so there is one technique that is called consistent hedging that will solve this problem. So what is that technique? Let's understand. So in the consistent hedging, there is one hash key. For example, this is the virtual key, right? For example, 0 to power 32, right? So and will be gold key, right? Now, so what is the technique is, we have to put the server key, let's say S1, S2, and S3. For example, S1, S2, and S3, put into the hash ring. For example, S1 here, S2 here, and S3 here. As well as we have to put the user key as well into the same ring. For example, user 1, user 2, user 3, user 4, user 5, user 6, right? We have to put the user key as well as into this, but how we can put? So we can simply take the hash of the server as well as hash of the key. For example, hash of server ID as well as hash of keys. Here key would be U1, U2. In similar way, the server key is S1, S2. In the same way, we have put the server key as well as the user key into the hash ring. Right now, to so now we have to, for example, if we have to figure out like user to where it will go, so we have to move the user to clockwise until we can find the server, right? So this is the server, this is the server, and this is the server. So now user 2 routes to S1. Similar way, for example, user 3. So we have to move clockwise until we find the server. So user 3 move to S3. Similar way, U4 we have to move clockwise until we find the server. So S3. So now U4 routes to S3. Right? And like we have placed the one point that I have to point it out. So here we have placed all the keys randomly based on the hash. So hash will like any random number, so we can put on this. So there is not any sequence. For example, S1 is always there, S2 is always there, S3. It will be random. Like S2 is goes here, S1 is goes here. Right? So this is the technique. Like we have to put server ID as well as the user ID based on the hash into the hash ring, and to find which user will move route to which server, we have to move clockwise until we find the server, right? So that is the technique. Now see like how it will solve the problem that we have like we have declared, we have like discussed before, right? For example, now server 1 goes down, right? Now this U1 and U2, its routes to S2. Why? Because this is down, and now if we move clockwise until find the server, then user 2 is route to S2. Similar way, user 1 routes to S1. But user 5 and user 4 and 5 still route to S3. Means it will not change, right? So only user 1 and 2 will be route to the S2. So in that way, it will solve the problem, right? Now if you see here, like if S3 have only 2 users, now S2 have 4 users, right? So the data is not distributed across. The like load is higher onto the S3 compared to S3. To solve this problem, what we can do is we can uh, create the virtual node of the server. What I mean say is, for example, as let's say was one example S10, S11, S12. Similar way S20, S21, S23. Sorry, 2. So similar way, we can create the multiple node of the server and put it here. For example, we can say S S10, S21. Here we can say S12. So similar way, we can put every node into the here. So we have to take the hash of it, and according to the hash, we have to put into summary, right? So in that way, we can distribute even load evenly into the hash ring. All right. So that is the virtual node actual technique. So in that way, we can distribute a load across multiple servers. So if in future any one of the server will down, so it will distribute the load of that failure server to the other server evenly, right? So that is the virtual node technique. Yeah. So that is the simply consistent hedging, correct? Now, what is the real world use case of this consistent hedging? So, consistent hedging is uses at multiple places. For example, the distributed databases, right? For example, Amazon DynamoDB, right? So, in that, for the data partitioning, for the similar example, they are using this consistent hedging technique. The another use case is the distributed caches, right? So cache server, for example, the Redis. So Redis internally uses this consistent hedging to store the caches across the multiple servers. So that is the second use cases. The third use case is load balancer. So if my server node is like what we can say stateless, right? I mean stateful means S1 is stored into the server 1, S2 is stored to the user 2 is stored to the S2. Means if my server is stateless and I have to distribute the load across that server, and I have to make sure that the session 1 is session 1 is only route to the server 1. In that case, as well in the load balancer, this consistent hedging used, as well as in the CDNs, like to route the request to the same server, as well this consistent hedging is used, right? So consistent hedging is widely used in multiple scenarios. Yeah, that's it from my end. Yeah, thank you for the watching, and please subscribe my channel and like my video. Thank you. Bye.